while he's working on that, let me just explain that. What I'm going to talk about today is sort of changes that had to be made to the code as a result of the, I suppose I can walk around like this. All right. So this book was published in 2014, and I knew when the book was published that I would have a problem keeping things up to date because things change pretty fast. I made a pretty radical decision when I did the book that I wanted to say that concepts were equally as important as programming, and so I made every second chapter a chapter that deals with code, and then of course, a lot of people who are professors these days don't have a lot of coding experience, and so I was sort of ahead of my game there. I think maybe the younger professors coming along will have a bit more JavaScript, as we saw in one of the presentations already. And so what I want to do is talk about some of the changes that have had to be incorporated, especially in the coding part of the book. So let me a little bit of history here. Let me know if I can find this. Yes, this is not going to be a little easy here. Okay. So there is on this website, and you can just do a Google search on mapping in the cloud. There is a section called Code, and in the Code section, the first chapters deal with basically HTML and JavaScript, and so I really don't get any mapping APIs until code 10, okay? And so code 10 then is where we start with actually making maps. And as you see, there are a series of examples here that deal with different APIs that were available. Okay, this goes back to 2009, 2010. In fact, one of the ways of looking at this is to see what's the sustainability of the code. Okay, we often don't look at things that way. Okay, we often don't say, will this code still work 5 years from now? Okay, we often look at code. Okay, we get it to work, and then we don't worry about it anymore. And then 5 years later, we go back and check, and it doesn't work anymore. Okay, but sustainability of code is something that's very important. So when I started looking at all these different APIs that were available, I have Google, and of course I have Bing and Nokia, and MapQuest and OpenStreetMap and Leaflet. And I looked at some China mapping APIs where they don't allow Google, and of course the Esri API, and do some pairwise comparisons on the bottom. Now, I know there are other APIs out there. I'm sorry, I don't have your API in here. It's hard enough keeping track of these and keeping them working after a few years. I was checking earlier today, and it'd be hard for me to find it, but in 2010, Google made a change from Google version 2 to Google version 3. It's a great big change, okay? Everything basically had to be rewritten at that point. But I went back to some examples that I have in Google version 2, and they still work today, okay? So of all these ones, I mean, if I go through this list of what's been the most difficult to maintain of all these APIs, so that they work every year when I teach about these things, probably the one that's been most difficult to maintain has been Leaflet. The one that probably most of you are familiar with, the one most of you use. Every time I come around to a semester where I'm using this code, I think, oh my God, is it still going to work? Okay, so I'm always worried that Leaflet's still going to work. Why? Mainly because they don't have their own map tiles, and so you don't know whether those map tiles that I used previously are still going to be there. Okay. Now I have to say, in the past year, I think it's been pretty stable, but it's been my major headache. Of course, a lot of these deal with some sort of. Let's just look at the first example here, and it's just a simple map. But if you go to the this is going to be, okay, good. I can do it that way. So here I talk about the Google examples. And a lot of the problem with Google is that they had a key, they required a key for a while, then they did not require a key, and now they require a key again, except if your server used it without the key before, then you're sort of grandfathered in, okay? And so it's really complicated to explain to students, you may need to get a key, okay, in order to make these work. So essentially, in Code 10, I'm just going through different examples and showing how different things work, such as a different kind of language. Do like that. So you can put different languages on. This goes through the layering concept and how we do vector tiles and how this is possible. Before this, 10 years ago, you brought up a map of Japan and you had English labels. You couldn't change it to Japanese, okay? And now you can. All right? So, that's code 10, just going through the different kinds of code. You may notice I'm missing Mapbox. Mapbox requires you to sign up. I don't want my students to go through that, so I don't have an example of Mapbox here. It's basically they don't have to do anything to make these work. Now with the Bing Maps, and by the way, every time I have students work with this, they always complain to me that they don't like these colors. They don't like these colors. Why are we even looking at these maps? They don't like these colors. Essentially, they're so used to Google Maps that they can't really adapt to anything else, which is an interesting phenomenon when you think about it. Because if you look back at the transition from MapQuest, which was actually the most used map site up until 2009, it took basically 4 years before Google overcame MapQuest. And MapQuest did not have a nice interface compared to Google. But it takes a while for people to get used to the new colors and new design. And once they're used to that, it's hard to switch them away to something else. All right? And they basically say that about a lot of these other things. So if you go down, Nokia is actually called Here Maps now. So names have changed along the way. MapQuest is still there, OpenStreetMap. It's also been a little bit difficult to maintain some of the OpenStreetMap code, Leaflet, the China mapping code companies, and then Esri API, which my basic complaint about Esri is that they're so slow, okay? They're so slow, and one of the arguments that I've made, you can also complain about the colors, I suppose, but the slowness of it, and I made the argument before that the best map, in an online world, the best map is the fastest map, okay? Which is an interesting argument because it's nothing about design or anything like that. It's the one that comes up the fastest. Down the bottom, I have some pairwise comparisons here, and I'm going to have to make these a little smaller. All right, so on one side is Google, and over here is OpenStreetMap. And so what we did is we do this, these two locations are chosen randomly, and this is a project for a student. They looked at each map and at the 18th zoom level, and they figured out whether they have the same number of labels, the same number of features and things like that. And so if you do this again, right, just do a refresh on it, it will find another place, someplace else, where there may be no features at all, okay? And you do this again, and we're out in the ocean someplace. Notice how Google is always faster than OpenStreetMap, even though I have OpenStreetMap code first, okay? Eventually we'll find some more features here and how they appear in both systems. By the way, the student found that in the United States, there are more features on the Google map. In Europe, there are more features on the OpenStreetMap, which is a long-term problem for us, I think, as we come up with a more standard map of the world. Let's go on to code 12 here, if I can get back up there. And by the way, the code 12 and code 14 are the most difficult ones. And the reason is, it's being a little slow, the reason is there's so many different file formats for bringing in the code. So it is not going there. Try it again. There it goes. So what's happened over the lifespan of this? By the way, let's go back to JavaScript. The problem with JavaScript, it was not designed as a language that really, there was no file format that worked with it. It was not designed to read in data from a file. Okay, that was 20 years ago, 22 years ago, when it was designed. They just wanted something to make web pages flashy. That's how JavaScript got developed. And so they came up with ways around that limitation. And so I'm going through different kinds of ways. Let me increase this a bit so you can see the file formats we're going through. So we have a kind of an XML file format. JSONs have been a fairly recent file format. Now it's extremely important in online mapping, but it's been fairly recent, especially with Google. Google did not have a routine that read in JSON files until 2014. Okay, and now it's such an important file format. It's hard to believe that they didn't support it until 2014. And the reason is they wanted to support their own file format, which was KML. Okay, and so KML is a nice fast format, but it has a bunch of problems. So there's some KML examples in here, some JSON examples, FusionTables, of course, and we're mapping out flight data using FusionTables and doing different kinds of symbols here as well. So a lot of Code 12 is about working with different types of data files, different ways of getting in a lot of points on your map. Okay, and that's what that's about. Now, Code 14 is another chapter that takes my students a long time to get through, because we're going through, again, a lot of different data file formats, like JSON and other file formats, but it's going through both lines and areas. So we're putting lines on a map and we're putting areas on the map using a bunch of different file formats, KML, GeoJSON, and so forth. Okay? And usually when we're dealing with a lot of points, students have to find other points to map out, and so it takes a bit of time to go through it. I tell them 12 and 14 are the hump, and once you get past the hump, it gets a little easier. And then in chapter 16, we take a very different approach. We're not mapping out points, lines, or areas anymore. We're essentially covering up the whole Google map. Okay, we're covering up the whole Google map with some sort of raster layer, and that raster layer can be initially just a JPEG picture, and then we cover it up with tiles. And so we take a map that's maybe in a TIFF format. We chop that apart in tiles, and those tiles go into folders, and they get displayed on the map. So down below here, and we're using a program here called MapTiler. But like this one, I think we'll eventually bring that up, and then you zoom down on that. And those are just a bunch of tiles. And you don't see the tiles coming up, but eventually they'll go away again because we're going down below the level of that. All right, so that's all layers based, and the idea of putting different kinds of layers on the map. All right, and then we get to Code 18. All right, and Code 18 works with PHP and MySQL. All right, now these are standard programs that are available on web hosting directories. And so what we're doing here is going through some background on PHP. All right, PHP is one of those languages that is used a great deal, right? It's used a great deal. It's not taught in universities because we're going for things like Python and other languages. But PHP drives like 80% of all web hosting sites. They're based on some sort of PHP and that is getting data from a back-end database, usually in MySQL. And so we go through a bit of PHP, which is another scripting language. Of course, the major difference is that this scripting language only works on the server, right? So it doesn't work on the client. And then we go through a series of examples where we have a MySQL database of some points and some lines and some areas, and then we map those out using PHP, grabbing the data from the MySQL database as we're doing it, okay? And then we even have a point input example. So what students need for this is a web hosting account that supports PHP and MySQL. All right, that's a requirement for this one. And really, it's a complicated series of concepts here, but the implementation of it goes fairly well. Okay, they learn how to populate MySQL database and do all those things. All right, Code 20. Code 20 has been one of the major issues for me over the years. Code 20 deals with using your phone to display a map, okay? And when you do that, you get asked whether you want to share your location, right? Do you want to share your location? Now, up until 2016, this wasn't a problem, okay? Students could take this code, could put it on their websites, could make a website that made a map of the person's current location, and you had to answer the question, you don't want to share the location, you'd say yes, and it would make a map of where you're located. All right, in 2016, they decided that this was like private information, which it is, right? And they made you serve this not from an HTTP site, but from an HTTPS site. So it has to be a secure site, okay? Now, usually I have students, create their own servers. I looked into them creating their own HTTPS site, and I decided this is impossible. It's too much for them to go through to create their own HTTPS site. So I did not do it that way. I created my own HTTPS site on my own server, which was quite a challenge in itself because you have to go through all kinds of certificates and things like that to do that. But it's possible. I'm not sure I could do it again, but I did it. And I think every year or 2 years I have to do it again. So I'm not looking forward to that. But you can create your own HTTP site. So when you do something like this, it will ask you, do you want to share your location, allow location access, and it will come up with a map eventually saying that that's not quite right, is it? But it's close. I don't know the area I'm in that well. There it is, the Sheraton Hotel. I'm guessing we're more in this area someplace?
On the south side.
Yeah, okay. So that's how that application works. By the way, the assignment for the students here is to screenshot this on their mobile phones, and that has been a problem in the past with some Android devices because they don't know how to do a screenshot of that. All right, and finally, we get to the code that we're going through in tomorrow's workshop, which deals with animation. And actually, there's not a lot of code in Google that deals with animation, so it should be a pretty easy workshop tomorrow. The thing is that initially, when these APIs came out, they didn't include much on animation. And what happened is people came along and said, okay, we can make this work, we can make animation work, and they wrote tons and tons of JavaScript to make animation work, okay? And then I was in contact with some people at Google who actually in Sydney, Australia, and I said, you don't have anything on animation. Here's an essay question I asked my students on what kind of tools Google should have incorporated to support animation. And so I sent them some of the best answers I got from my students. And a couple of years later, they incorporated some of those tools, which of course makes their API a little heavier, but it does have some examples of animations. And I don't know, this one kind of goes slow. We'll work tomorrow on making this go a little bit faster, but this is the growth of Walmarts in the United States. And the Walmarts in Canada too, but they don't come across on this map. So we'll work on ways of changing the attributes of that animation, which is, by the way, pretty much what I try to teach my students. I can't make programmers out of my students, but I can make them understand the code a bit and understand what they need to change about the code to map out something else or to map out something else in a different way. Okay, thank you.